geometrical meaning of the zeros of a polynomial. Let us consider p of x is a polynomial which is represented in terms of x. If you want to find p of k, then we have to find p of x at x is equal to k. That is, we have to substitute the value of k in the place of x in the given polynomial equation. After finding p of k, if we found p of k is equal to 0, then we consider k as the 0 of the given polynomial equation. But have you ever think, why are the zeros of a polynomial so important? To answer this, first we will see the geometrical representations of linear, quadratic and cubic polynomials and the geometric meaning of the zeros. Okay. Let us consider a linear polynomial y is equal to ax plus b. We all know that the graph for y is equal to ax plus b is a straight line. So let us take an example of y is equal to 2x plus 3. So in order to plot this graph, we require at least 2 points. So I want to find these points using x value for minus 2 and x value as 2. Why? Because I am choosing minus 2 to 2. That is, I am considering a line equation having a range of minus 2 to 2. So I am taking what are the corresponding y values for the given x values. So when x is equal to minus 2, I am getting y is equal to minus 1. And if x is equal to 2, I am getting y is equal to 7. So when I draw a graph for the equation of y is equal to 2x plus 3, here it is a straight line which is passing through these 2 points 2, 7 and minus 2, minus 1. Okay. Now from the graph we can clearly observe that the straight line intersects the x-axis at exactly in between minus 1, minus 2. So we all know that the graph where it intersects the x-axis is called the zero of a particular linear polynomial. So if we want to know the point at which the line intersects the x-axis, we have to find the zero for the given polynomial equation. Okay. The given equation is p of x is equal to 2x plus 3. If you want to find 0, that is, we have to find p of k and then equates to 0. So p of k, which is equal to 2x plus 3, and when equates to 0, it becomes 2x plus 3 is equal to 0. From that, we can getting k value as k is equal to minus 3 by 2. So minus 3 by 2 0 is the point at which the line y is equal to 2x plus 3 exactly intersects the x-axis. Okay. Now in general, y is equal to ax plus b is a linear polynomial and the graph of y is equal to ax plus b is a straight line which exactly intersects the x-axis at only one point, namely minus b by a 0. Okay. Now let us look for the geometrical meaning of a zero of a quadratic polynomial. Okay. Let us consider a quadratic polynomial, that is x squared minus 3x minus 4. So in order to draw a graph, in order to plot a graph, we require some points. So I want here to find the corresponding points, right? So if I take x is equal to minus 2 and you substitute x is equal to minus 2 in the equation y is equal to x squared minus 3x minus 4, I am getting y value as 6. Similarly, if x is equal to minus 1, then y is equal to 0. If x is equal to 0, y is equal to minus 4. If x is equal to 1, then y is equal to minus 6. If x is equal to 2, then y is equal to minus 6. If x is equal to 3, then y is equal to minus 4. And if x is equal to 4, then y is equal to 0. And if x is equal to 5, y is equal to 6. So here While we observe in the table, we can clearly see that minus 1 and 4, for these two values of x, the resultant y will become 0. That is, the total equation x square minus 3x minus 4 becoming 0. Hence, these 2 points are said to be called as zeros for the given equation x square minus 3x minus 4. Okay. After plotting the graph, we can clearly observe that the graph is an upward parabola which intersecting the x-axis at mainly 2 points, that is minus 1 comma 0 and 4 comma 0. Hence, minus 1 and 4 are called as zeros for the given quadratic polynomial. Okay. Now, the general equation of quadratic polynomial is y is equal to ax squared plus bx plus c. So, the shape of the quadratic polynomial varies with whether the a greater than 0 or a less than 0. That is, if the a greater than 0, then the shape of quadratic polynomial is an upward parabola, and if a less than 0, then the shape of a quadratic polynomial is downward parabola. Okay. Now, based on the intersection of graphs with the x-axis, again these can be classified into 3 cases. Case 1. If the graph cuts the x-axis at 2 distinct points, that is, here in the graph we can clearly show that the graph cuts the x-axis at 2 different points. Hence, the zeros for this equation is 2. See, second case, if the graph cuts x-axis at exactly 1 point, that is at the coincident points. So, the 2 points A and A dash of case 1 coincidence here become to 1 point A. Hence, it has only one intersection point with the x-axis. So, the number of zeros in this case is only 1. Case 3. Here the graph is either completely above the x-axis or completely below the x-axis. So, it does not cut the x-axis at any point. So, here the number of zeros in this case is 0, since the graph does not cut or intersects the x-axis. So, what we are saying is that generally the quadratic equation having the highest degree of 2. So, it can possess at most 2 zeros, that is, it have either 2 distinct zeros or 2 equal zeros, that is 1 zero or no zero. So, there are 3 cases. It may vary depend upon the equation they have given. Now, let us find the geometrical meaning of the zeros of a cubic polynomial. Okay, let us consider a cubic polynomial x cube minus 4x. So, to plot the graph, we require some points. So, a point is nothing but the coordinates of x and y. Okay, so I am taking x value as minus 2, and if I substitute x is equal to minus 2 in this equation, y is equal to x cube minus 4x, then I am getting y value as 0. Similarly, if x is equal to minus 1, then y becomes 3. If x is equal to 0, then y becomes 0. If x is equal to 1, then y becomes minus 3. If x is equal to 2, then y becomes 0. So, from table itself, we can clearly understand that from the 3 values, that is minus 2, 0, 2, 3 values of x, we are getting 0 for y. That is, these 3 values minus 2, 0, plus 2 are considered as the zeros for the given cubic polynomial x cube minus 4x. Okay. When you plot the graph, we can clearly see that the graph intersects x-axis at mainly 3 points, that is at 2, minus 2, 0 and 0, 0 and 2, 0. So, by this we can clearly say that minus 2, 0 and 2, these 3 are considered as zeros for the given cubic polynomial. Okay. Now, let us take a few more examples. Consider the cubic polynomials x cube and x cube minus x squared. Okay. The graph for x cube are here. So, we can clearly see that the graph intersects the x-axis at exactly at 0. That is, it can intersect only one point. So the number of zeros for this equation x cube is 1. And coming to the second example, x cube minus x square, the graph of x cube minus x square is like this. So here it intersects the x-axis mainly at 2 points, that is at 1 and that is at 0. Hence it containing 2 zeros. So what they are saying that in general the highest degree, the highest power of variable present in cubic polynomial is 3. Hence the degree of cubic polynomial is 3. So we can make at most 3 zeros for a cubic polynomial. That is, either in some cases we are getting 3 zeros, or in some cases we are getting 2 zeros, and in some cases we are getting 1 zero. So in other words, a polynomial p of x of degree n, the graph y is equal to p of x intersects the x-axis at most n points. Therefore, a polynomial of degree n has at most n zeros.